Importance of pH in everyday life. The first example we will take is of the body. Now our body works in a pH, in a specific range of pH. So the body works with a pH, within a pH range of 7 to 7.8. If the pH becomes less than 7 or more than 7.8, this affects the metabolic activities of the body. So the pH level of a body is between 7 and 7.8. The next importance of pH is acid rain. Here we will see how acid rain is formed. Here we have the factories, and these factories give out sulfur dioxide, nitrogen dioxide, carbon dioxide gases. These gases now mix with or combine with water from the rain, and when they combine with the water from the rain, we get acid rain. So here is the water, and now it's combining with these gases of nitrogen dioxide, sulfur dioxide, carbon dioxide to give you acid rain. So basically acid rain is formed when rainwater combines with pollutants like sulfur dioxide, carbon dioxide, nitrogen dioxide to give you acid rain. Now, the acid rain is harmful if its pH is less than 5.6. If the pH drops below 5.6, that acid rain is harmful. And we have seen the harmful effects of acid rain. Like in this case, you see the acid rain will now enter into the river, and from the river then it will enter into a water body, and it affects all aquatic life, like the fish and other aquatic life gets affected by this acid rain, because the whole water body will now become acidic. Another importance of pH in everyday life is that of the soil. The soil also has its pH, and plants are very sensitive to pH. Plants grow within a specific pH. For a healthy growth of a plant, the farmer has to maintain the pH of the soil, which means if the soil is acidic, then what will the farmer do? He will probably add a base to it, a base like calcium hydroxide to it, which is basic, and thus it will neutralize the soil and make it less acidic. So this I will now learn about pH in our digestive system. This is the picture of the stomach, and in the stomach we have the HCl, or the hydrochloric acid, which helps in digestion without harming the lining of the stomach. In life processes, you have learned we have the mucus, which protects the layers of the stomach, and hence the HCl does not affect the walls of the stomach. HCl is present in the stomach and helps in digestion. However, there may be a situation when there is an excess of HCl. And when there is an excess of HCl, it would affect the lining of the stomach, which would cause pain and irritation. And this condition is called acidity. Okay, this acidity, it is not a very good condition. It causes pain, irritation, indigestion in the stomach. Now, to reduce the acidity, we take an antacid. We take an antacid, which is basically a base, like example is milk of magnesia, which is MgOH twice. Now in this case, the excess acid now reacts with the antacid which is a base, and neutralizes it. And hence we get relief from the pain and irritation. So just to go over it, we said in the stomach we have the HCl, and this HCl is helpful or helps in digestion, but in some conditions there may be an excess of HCl, and this excess of HCl affects the walls of the stomach, and when it affects the walls of the stomach, it causes pain and irritation. This condition is called acidity. So for a cure for acidity is to take an antacid. An antacid is a base, like milk of magnesia, magnesium hydroxide. This antacid here neutralizes the acid. The antacid, it neutralizes the excess acid. We'll now study pH change as a cause of tooth decay. So we'll see how pH plays a role in tooth decay. To begin with, let us learn about the tooth. Now the tooth, the outermost covering of the tooth is called the enamel. It is the hardest substance in our body. It is harder than the bones. It's the hardest, and it is made up of calcium phosphate. It is very protective. So let me repeat again. We said this enamel, which is the outermost layer of the tooth, is the hardest substance in the body and is made up of calcium phosphate. We always have learned that when we eat too many sweet things, our tooth decays. Now we'll see the reason for that. Now when we eat sugars, and we have the bacteria in our mouth, this bacteria in our mouth, they turn the sugars into an acid. This acids then react with the enamel and cause the tooth decay. They dissolve the enamel. This happens when the pH of the mouth is less than 5.5. When the pH of the mouth goes below 5.5, the acid begins to attack the enamel. Now remember, we did not eat any acid. We have eaten sweets. And in the sweets, there is sugar. The sugar is converted into acid by the bacteria. Here is a picture of tooth decay. Have you seen how the enamel in this case is been slowly eaten up by the acid? It keeps on deeper and deeper and deeper, and when this tooth decay reaches the innermost part of the tooth, it begins to hurt. So basically it is the acid that is dissolving the enamel. So when the acid is reacting with the enamel, acid reacts with enamel to cause the tooth decay. So to neutralize the acid, we would definitely require a base. If we add a base here, the acid would be neutralized, and that is why we brush our teeth with toothpaste. Toothpaste is basic in nature, and because it is basic in nature, it neutralizes this acid. So this acid here is neutralized by toothpaste, and that's the reason why we brush our teeth after eating the sugars. The basic toothpaste, which is basic, neutralizes or nullifies the effect of the acid. So here's a picture of the toothpaste, and this toothpaste is basic. Because it is basic, it neutralizes the acid and hence protects the teeth. Self-defense by animals and plants to chemical warfare. So here we see a picture of a bee stinging a person. When a bee stings a person, it injects in the person an acid. So this entire area gets infected or is covered by an acid, and this acid spreads into the skin of the person. This causes pain and irritation. So we see that this is an acid that gets injected. Now in order to neutralize this, you'll definitely agree we would have to add a base. So we use a base like baking soda. Baking soda, we have learned, is sodium bicarbonate, and it is basic in nature. It neutralizes the acid. So the remedy for a bee sting, the remedy of a bee sting is a base. The base reacts with the acid which is injected by the bee and neutralizes it, thus giving relief. Here's another great example of animals and plants using pH. These are a picture of nettle leaves, and if you touch these nettle leaves, they give out methanoic acid, and this methanoic acid, when it enters the skin, it causes irritation. So when a person touches these nettle leaves, these are all nettle leaves, your hand begins to scratch, and the reason is because of the acid. The acids present in these nettle leaves. And next to the nettle leaves, you'll always have this dock plant. These are the dock leaves. And now these dock leaves, they have a base. They are basic in nature. So if these dock leaves are rubbed against the nettle leaves, it will neutralize the acid in the nettle leaves and thus relieves the pain. So here we rub dock leaves. When you get this pain from or the irritation due to nettle leaves, we rub them with dock leaves, and these dock leaves are basic. They produce a base. So the acid from the nettle leaves is neutralized by the base from the dock leaf and thus releases the pain. We'll now talk about some naturally occurring acids. Here's a picture of a vinegar, and vinegar contains acetic acid, and that is why it is sour. Here we have oranges, and this orange contains citric acid. That is why they are called citric fruits. Orange are called citric fruits. It contains citric acid. The next is tamarind. This is tamarind, and it is sour because it contains tartaric acid. Then here's the tomato, and tomato contains oxalic acid, and hence it is also slightly sour. This is curd, and curd contains lactic acid. These are acids that we have in our food. This is a lemon, and lemon also has citric acid, so that also is called a citric fruit. And here is an ant bite, and you know, every time we have an ant bite, it hurts us, right? And because the ant gives out an acid here in the skin, and that acid is methanoic acid, just like the bee. When we touch the nettle leaves, also we get pain and irritation. These are nettle leaves, and this is because also they give out methanoic acid. So these are some of the pictures of naturally occurring acids.